Okay, so we know if the absolute value of x equals 12. We know that x can equal 12, but x could also equal, or x could also be negative 12. So we know x can equal 12 or x can equal negative 12. Because absolute value changes everything to positive because it's really just telling you the distance a number is from 0 on the number line, and distance is always positive. Okay, so what happens when we have an absolute value equation? If we have, say, I ask you to solve the absolute value of 3n minus 5 is equal to 7. Now, in the past in middle school, you guys have always done, okay, well, you'd made two separate equations. 3n minus 5 equals 7. And then you would also do 3n minus 5 equals negative 7. Do we agree? That's how you would do this. That's absolutely right, and that is what we're going to do. I'm just going to take it a step back just to ensure that we really understand what's going on. Because it's not really just about negating what comes after the equal sign. Why are we negating what comes after the equal sign? Because really what's getting negated is not what comes after the equal sign. It's essentially the expression inside the absolute value sign, right? So what's really happening is they're saying, okay, we're going to take the positive version of 3n minus 5 and set it equal to 7. But then there's also the negative version of 3n minus 5. So they're also saying, well, there's the negative version of 3n minus 5 equals 7. And instead of distributing in that negative, essentially what we're doing is just dividing by negative 1, and that's why we make that a negative 7. Does everybody understand that's how we get that number to be negative? So essentially what they're doing here is just dividing by negative 1, and that's how we get the negative number on the other side of the equal sign. It was just done more of like a shortcut. Let's just shortcut it right away and make that positive and that negative. But the concept of really we're just negating the expression inside the absolute value line, that's very important for like algebra 2 concepts, that you understand that's essentially what we're doing. So we're going to have 3n minus 5 is equal to 7, and 3n minus 5 is equal to negative 7. And then we're going to solve. So we're going to have 3n equals 12, so n is equal to 4. Then we're going to have 3n, I'm going to add that 5 over, is equal to negative 2. So n is equal to negative 2/3. All right. I'm going to put a star here. We need to check all absolute value problems to make sure both answers work. So the way we check is we go back to the original equation, 3n, the absolute value of 3n minus 5 is equal to 7, and we're going to substitute in our numbers. We'll check the 4 first. 3 times 4 is 12, right? 12 minus 5 is 7. Absolute value of 7 is 7. So we got 3 times 4 minus 5. We get 7 is equal to 7. That works out. Now let's check the other one. 3 times, what was it? Negative 2/3? Yep, negative 2/3 minus 5. Does that equal 7? Well, when you multiply a whole number and a fraction, we can cross simplify. So we get negative 2 minus 5. Negative 2 minus 5 is a negative 7. Absolute value of negative 7 is 7. So both answers check out here. Okay, now let's talk about an absolute value inequality. If I have the absolute value of x is less than 4, we have a bit of a problem here. So we can say, okay, well, x will just be less than 4. Bam, we're done. Does that work if I just say, okay, just make x less than 4, and it will fit this criteria? No, because isn't -5 less than +4? If I plug -5 into the absolute value, what's the absolute value of -5? +5. Is that less than 4? No. So we need restrictions here. So what you do with an absolute value inequality, you're going to come up with 2 different inequalities. You're going to take it exactly as it is, remove our absolute value signs. So I'm going to say x is less than 4. But then you're going to come up with a different absolute value. You're going to say x, now flip the sign, is greater than the negation of it, greater than -4. But now I have 2 inequalities. Is it an and or is it an or? Let's see. Let's say it was an or. When it's an or, it fits this one or it fits that one, right? As long as it's in one of these, it will cover it all. Well, you tell me, will it always fit this one? No, it won't always fit this one. Will it even always fit this one? No. So it's definitely not an or. So what does that mean? It has to be and. So it has to be less than -4 and it has to be, less than +4 and it has to be greater than 4. And let's see what that looks like. Here is -4, here is +4. It is saying we are between these 2 numbers. Think of all the numbers between -4 and +4. Does it work if we plug in any number between -4 and +4?
Yep.
It always works. So what does this mean? When we have an absolute value inequality, if the inequality is the less than symbol, it means you're more restricted, which means and or is more restrictive. And is more restrictive, right? So when it's less than, it's always going to be an and problem. Absolute value inequality less than will be an and problem. What's up?
What if you had absolute value x less than -4?
That would be a no solution because can an absolute, okay. All right, so now let's see. So what would be our solution here? So just to sum this up for us, the absolute value of x is less than +4. Our solution set would be x such that x is less than 4 or, oh, sorry, not or. Actually, no, that's not how we're writing it. Sorry, we're going to write it as one inequality altogether. X such that -4 is less than x, which is less than 4. There we go. Okay, now let's just look at the or scenario. Let's say I have the absolute value of x now has to be greater than 4. So we're going to split it into two different inequalities. How do we split it into two different inequalities? We're going to say x is greater than 4, x is less than negative 4. Does everybody know, I just assumed you knew, does everybody know where we get this second inequality from? No? All right. Where we get this second inequality from, we know x has to be greater than 4, right? But don't we also know, since this is absolute value, the negation of x also has to be greater than 4, whatever that is. So that's when you divide by -1, and that's why we get x is less than -4. So that's why we always do that. We keep one the same, and then we flip and negate. That's how we get those two inequalities. Keep one the same, then flip and negate. Because we have to keep in mind, this x can be positive, but this x could also be negative. So we account for both scenarios. Okay, going back. So here we have x is less than -4. So is it an and? Is it an or? Well, let's think about this. X is greater than 4. Is there a number you can think of that's greater than 4 that if we plug into this, it will not work out? Every number greater than 4, if we plug into it, it will work out, right? Now let's think about x is less than -4. Think of every number under the sun that's less than -4. Is there any number that if you plug into this, it will not work out? I think they all work out, right? So as long as it's in this one or it's in this one, will it work out? Yes. So is it an and or an or? It's an or. All right, so think of it this way. If the absolute value inequality is a less than is more restrictive, it's an and problem. If it's greater than is not restrictive, it's an or problem. So let's write that down. Absolute value / greater than is an or problem. So our solution set becomes x such that x is greater than 4 or x is less than -4. So for an and, we write it as one compound inequality altogether. For or, we write two separate inequalities with the word or in the middle. Yes, Sean?
So you couldn't write like -4 is greater than x, which is less than -4. Like you couldn't just combine it.
No, because when you combined it, it immediately means an and problem.
Okay.
So only and problems are combined. Absolutely. If you wanted to do interval notation for this, it would be the -∞ to 4 union or the word or 4 to infinity, everything parentheses.
How is it union?
Because union means or, intersection means and. So union means or. But you can just write the word or if you prefer it. You don't have to use the union. All right, let's do another problem. Anybody still copying? So the absolute value of 4y plus 2 is less than 10. And we're assuming for all of these absolute value problems, the absolute value is still greater than 0. Okay, the absolute value is still greater than 0. So there's that restriction on this. All right, what are we going to do? We're going to say 4y plus 2 is less than 10. That's one inequality. Now, this was a less than symbol. It's less than, so is it going to be an and, or is it going to be an or problem? And it's going to be an and problem. So for less than, it's an and problem. And 4y plus 2 is greater than negative 10. All right, so now we solve these two inequalities. So we're going to subtract 2 from both sides. We're going to have 4y is less than 8, so y is less than 2. And now I'm going to solve the other one. 4y is greater than negative 12, so y is greater than negative 3. So now we're going to write this, because it's an and, as one inequality altogether, y such that negative 3 is less than y, which is less than positive 2. If we were doing interval notation, it would be negative 3, comma 2.
Why do we have to check our answers for the equations and not for the inequalities?
So sometimes for absolute value equations, there's something called extraneous solutions, which doesn't fit the domain. But for inequalities, it always works out within the domain. Okay, let's do another one. Okay, you all try this one on your own. Absolute value of 2n minus 1 is greater than or equal to 5. Alrighty, who has an answer for me? Sean.
X such that n is greater than or equal to 3, or n is less than or equal to -2.
How many people got that? n is greater than or equal to 3, or n is less than or equal to -2. Perfect. If I asked you to graph this, would you know how? I hope so. So we'd have 0, and then 1, 2, 3, -1, -2, -3. So we would do closed circle over -2 to the left, closed circle on 3 to the right. All right, let's step it up a bit. Are we ready to step it up? No, we like it like this. All right. Absolute value of y plus 5 is less than or equal to 2, or the absolute value of y minus 5 is less than or equal to 2. So absolute value of y plus 5 is less than or equal to 2, or the absolute value of y minus 5 is less than or equal to 2. So we have a lot going on here, right? Because this alone is a lot, and then this alone is a lot. But then we're taking our final things from here and here and then using them as an or. So we're going to go through this step by step. Let's work on the left side. Let's find our solution set for our left side. How do we do this? We're going to say y plus 5 is less than or equal to 2, and or. And, good, y plus 5 is greater than or equal to -2. And then we solve. So we're going to have y is less than or equal to -3, and y is greater than or equal to -7. I'm not going to write it out. I'm just going to graph this right now. Make it more room for our negatives. So we are between -3 and -7, right? It's an and, so it's right between those two. All right, now let's work on the other side of the equation. If at any point you feel that I'm going too fast, just tell me to slow down. So now we have y minus 5 is less than or equal to 2, and or, and y minus 5 is greater than or equal to -2. And we solve. So y is less than or equal to 7, and y is greater than or equal to +3. I'm actually going to line it up right underneath the other one. We can even extend the other one a little further. Okay, so we're closed circle on 3, and we're closed circle on 7, and we're right between them. Now, what was between the two different inequality absolute value equations? It was an or, right? Wasn't it an or? So what does that or mean? If it's in this top graph or it's in the bottom graph, can it make it to our final solution? Absolutely. Is there any overlap at all that we can condense this? There's no condensing this. There's no overlap at all. Actually, if this was an and problem, what would be the answer? No solution. But because it's an or, this graph works, and this graph works. So we're going to set up our final solution set. So we're going to say y such that, and we're going to write down the two inequalities. -7 is less than or equal to y, which is less than or equal to -3. We could use the word or. 3 is less than or equal to y, which is less than or equal to 7. The graph would be that. That would be our graph. Anybody want to see interval notation? Okay, interval notation would be -7, -3, oops, square brackets, or union, whichever one you prefer, 3, 7, square brackets. All right, our last problem for today. Can I go on? Oh, yes.
I still don't get the square brackets thing. What is it again?
Oh, okay. Do you see how we have the line underneath the inequality sign?
Yeah.
So that means it could be equal to -7 or equal to 3. So the square brackets means it could be equal, so it's in our solution set. If it's not in the solution set, it's rounded.
Okay.
Yes?
Could you write 3 is less than or equal to the absolute value of y is less than or equal to 7?
Yes, you can. All right, can we keep going? Yes?
For what he said, is that for interval or for set notation? Both.
He's saying set notation because he's saying he's taking it a step further, but I have a restriction sort of like in general in this class that we're not going less than negative. So the whole absolute value has to be greater than 0. So he's just taking it that step further. Okay, we ready to keep going here? Okay, next one. So we have the absolute value of 2y plus 4 plus the absolute value of 6 minus 2y equals 22. Okay, so this goes back to why I had first started off when I had said, okay, when you have like x plus 5 equals 11, this goes back to the fact that I told you don't understand that this is x plus 5 equals 11 and also the negation of x plus 5 equals 11, right? This is how I started this whole lesson today. Understand that this is what we really have here. And the reason I was explaining this from the beginning versus just saying, okay, this is 11, this is -11, is for problems like this exactly, right? There is a shortcut here. I will tell you the shortcut. Well, it's still long, but it's sort of a shortcut in your thinking. Right now, because we have two different absolute values, we know that the quantity inside this absolute value can be positive, and also it can, the value inside this absolute value can be positive, and the value inside this absolute value can be positive, right? We can have two positives. Positive first one, positive second one. Do we agree? But we can have the value in this absolute value be positive and the value in this absolute value be negative. So that means we can have the first one be positive and the second one be negative. Do we agree on that? Okay. Going back. Can I have the quantity in this absolute value be negative and the quantity in this absolute value be positive? So then we would have one negative and one positive. And then what's the last scenario? They both can be negative. Well, we are going to work out those scenarios. We are going to work out those scenarios and see what happens. So if both of them are positive, all we do is just take the quantities out of the absolute values and set up our equation. So this is 2y plus 4 plus 6 minus 2y equals 22. Everything just comes out positive. Or as it is, I should say. So now we combine our like terms. And when I combine my like terms, I have a positive 2y and a negative 2y. Does that work? No, they cancel out. So I end up with 10 is equal to 22. Is that a true statement or a false statement? That is a false statement. So does this work? No. So for them both to be positive does not work. All right, let's go on to the next one. The next one is saying keep my first one positive, 2y plus 4. But now negate the second one. How do I negate the second one? I do a negative parentheses 6 minus 2y equals 22. All right, let's keep going now. Distributing that negative. So we are 2y plus 4 minus 6 plus 2y equals 22. Combine our like terms. I get 4y minus 2 equals 22. 4y equals 24, so y is equal to 6. Do we have to check this? Yes, it's an absolute value equation. You have to check your answers. So let's just quick plug in the 6. 2 times 6 plus 4. 2 times 6 is 12 plus 4 is 18. And then 6 minus 12. 6 minus 12 is negative 4. Absolute value of negative 4 is 4. Is 18 plus 4 22? Yeah, so does that answer work? Y equals 6? It does work. We're not done. Why are we not done? There's still 2 more to check. So now we're checking, what did we do? Positive, 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 negative, negative, positive is next. So we're going to negate the first one. Keep the second one the same. Equals 22. Distribute in that negative. So here we're going to have negative 2y minus 4 plus 6 minus 2y equals 22. Combine our like terms. Negative 4y plus 2 equals 22. Y will equal negative 5. Right? Yes. Should we check it? Yes, let's check it. Negative 10 plus 4 is negative 6. Absolute value of negative 6 is 6. 6 plus 10 is 16. 16 plus 6 is 22. Does this work out? Yes.
How did the 4's one being positive and the 7 being negative, y equals 6. How did that work out?
How did the 6 work out? You want to see the check? Is that what you're saying? Okay. So we have 2 times 6 is 12. 12 plus 4 is? Absolute value of 16 is 16. Then we're going to have, what was it? Y equals 6. So 6 minus 12 is negative 6. Absolute value of negative 6 is 6. 16. Okay. All right, and the last one, what are we doing? Negative, negative. So we have the negation of the quantity of 2y plus 4 minus the quantity of 6 minus 2y equals 22. Distribute in, negative 2y minus 4, negative 6 plus 2y. Right off the bat, what happens with the 2y's? They cancel. So does this work out? No, you end up with negative 10 equals 22, which is not a true statement. So what are our solutions here? We have y equals negative 5 and y equals, what was the other one too? 6. Okay, thank you. Those are our 2 solutions. So most of the time, I hate to say always, but basically, generally speaking, if the plus plus doesn't work, the minus minus isn't going to work. And if the plus minus works, the minus plus will work. So it's either these 2 work or these 2 work. Yes?
It's never going to be the same for like all of them, or like?
There is the scenario where it could be, okay, all of them would work, but then generally it would be like all real numbers, which I believe if it were going to be all real numbers, even when you came down to like the first one, the plus plus, it would be all real numbers. Like it would be like 10 equals 10, which in that scenario is all real numbers, so all of these should work. Yes?
Is there ever a situation where none of them would work?
No solution? Yeah, anything's possible. But generally speaking, if this one works, this one will work, and if this one works, this one will work, and the other 2 will not. All right, we are done for today.